Today we're looking at simple interest. For those of you who did pre-general last year, this is very similar to what we've already done. For those of you who haven't, we'll be looking at using recurrence relations to calculate this. Now, simple interest is built on either an investment of money that you've earned and earning interest over time, or paying interest from borrowing money, perhaps from a bank or a lender. It's calculated using a percentage of the principal or the amount of money borrowed or invested, and it's usually known as a flat rate interest. So it goes up exactly the same amount every year or every term. Generally, it's yearly. So for an example, an amount of $2,000 invested in an account earning 6%, simple interest will have 6% of that $2,000, so $120 a year. And we can actually calculate this through a recurrence relation. So if we let Vn be the value of the investment after nth year, or it could be first, second, third, fourth year, whichever one you're calculating, you can use the recurrence relation as V0, which is our initial value of $2,000 in the question, and every value after that, the next year being V1 or if it's V2, is calculated by using the value of the number before and adding $120 to that. In this case here, if this was Vn plus 1 or 0 plus 1, we would use the value of 0, which is 2,000 plus 120, which would give us the value after the first year of being $2,120. And you can also graph this as you see here. So we've started at year 0 being 2,000, 2,120, we add 120 again, 120 again every year as we go up. So you can see that this is a linear relationship between the number of years and the value in dollars. So we're going to have a look at a couple of examples in a moment. But you can see here you've got V0 being our starting value, so that $2,000, and when we calculate each year or each year after, we use the year before and we add the D, which is the amount of interest earned in that time period. And that's calculated by using the interest rate over 100 times by the initial value, and we did that before. There's also a general rule here that states very much the same thing. Okay, so we're going to have a look in example 1. Penny invests $4,000 in an account earning 5% of simple interest per year. The recurrence relation for this investment after n years, we are going to write as follows. We need to find out the actual rate, or the D value, which is R, the rate, which is 5%, over 100, times by the initial value being 400. That gives us a value of 200, or actually that's 5% of 4,000, that should be written there. So 5% of 4,000 is 200. The initial value is 4,000, so this here is our recurrence relation. 4,000, comma, Vn plus 1 equals Vn plus 200, which means the value before it, we're adding 200 to each time. We can then make the general rule by adding that 4,000 into the rule. Whatever value we're looking for is going to be equal to 4,000 plus the number of years. Now this value here will be the same as this value here, times 200. Or you can write it as such. We can then use that general formula to determine how much interest she will accrue over that time. If n is 6, being 6 years, then and the D value is 200, so she's adding $200 of interest each year, you'll have the initial value 4,000 plus 6 times 200, so the number of years times the 200, the value, which is 5,200. Value of investment after 6 years. If we then use that value, we can subtract the starting value, and again they've written 400, but that should be 4,000. You end up getting an interest of $1,200 over that 6 years that you've paid. What will her investment grow to in 7 years? Again, we use the general formula. The initial value is 4,000. The number of years is 7, and the rate that we're going up is 200 every year. So if we go put those in, we end up with $5,400 over 7 years.